Good morning. Today we'll be talking about polynomial functions and their graphs. When we talk about polynomial functions and their graphs, this is something that you guys have never seen before. Okay, first, definition of a polynomial function. Basically what you'll see here is you'll be seeing different types. Polynomial functions, examples. F of x equals 5, f of x equals 2x plus 7, f of x equals 2x to the 5th plus 3, f of x equals 4x to the 3rd minus 3x squared. Those are all examples of polynomial functions. Not polynomial functions. F of x equals 4 over x. F of x equals the square root of x. F of x equals 3x over x minus 4 to the second power. F of x equals 2x to the 1/3. Those are all examples of ones that are not polynomial functions. Polynomial functions of degree 2 or higher have graphs that are smooth, contain only round curves with no sharp corners, and continuous. They have no breaks. Okay, that means it can be drawn without lifting your pencil. If f is a polynomial function of degree n, then the graph of f has at most n minus 1 turning points. I will explain that. The behavior of the graph to the far left or the far right is called its end behavior. Okay. So here's end behavior, the leading coefficient test. Okay, so end behavior can be odd or even. Okay, so what's odd? 1, 3, 5, 7. Even 2, 4, 6, 8. Okay. So, let me move this up. I'm going to explain to you odd end behavior. Okay, LC stands for leading coefficient. Okay, so we're going to draw this. Okay, so now with the leading coefficient positive. Okay, that's positive, positive. Negative, negative. Okay, think about, and this is the best way to remember this. Think about quadrants, okay? The 4 quadrants. This quadrant is positive, positive. This is a negative, positive. This is negative, negative. And this is positive, negative. Okay, so here's how we write the end behaviors, okay? As x, see how I'm making this arrow? You say approaches negative infinity. Y approaches negative infinity. Okay, now why am I writing that? See this quadrant right here? That's negative, negative. X approaches negative infinity, Y approaches negative infinity. Okay, now what am I going to write here? This is positive, positive. So I'm going to say as X approaches positive infinity, Y approaches positive infinity. That's what that end behavior means. Okay, guys, you're going to have to memorize this. Okay, when the leading coefficient is negative. Okay, when the leading coefficient is negative, odd, negative, it's going to go this way and this way. Okay, now, what is this quadrant? This quadrant goes what? This is a negative and a positive, and this is a positive and a negative. Okay, so we start on the left side. As x approaches, what's that? Negative infinity. Y approaches, what's that? Positive infinity. Okay, as x approaches, what's that? Positive infinity. Y approaches, what's that? Negative infinity. That's what that means. The best way to do it, guys. Okay, so that's odd. This is odd positive, odd negative. All right, and at the end, I'm going to look like an idiot, and you'll see me look like an idiot, showing odd positive, odd negative, even positive, even negative. Okay, next, even degree. Okay, so what does end behavior when it's even positive look like? Okay, when it's even positive, it looks like this. Okay, so now, even positive, this is negative positive, and this is positive positive. So, end behavior is as x approaches, what's that? Negative infinity. Y approaches, what's that? Positive infinity. As x approaches, what's that? Positive infinity. Y approaches, what's that? Positive infinity. Okay, and then odd negative, last one. I'm sorry, not odd, even negative, excuse me. Goes down like that. Okay, even negative, that's negative, negative, and this is positive, negative. Can we see that? Okay. So as x approaches negative infinity, y approaches negative infinity. And then as x approaches negative infinity, positive infinity, y approaches negative infinity. All right, so that's just something you guys have to memorize, and the best way to memorize this is to understand what the quadrants are. Negative, 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 negative. Positive, negative, positive, negative. Okay, so that is called end behavior. All right, so now we're going to determine the degree. These problems here. We're going to determine the degree, the leading coefficient, and the end behavior. This is going to be very similar to your first homework. Degree, leading coefficient, and end behavior. Okay. First problem. Okay, so what is the degree here? Well, the degree is a 7. So, degree, leading coefficient, and behavior. Okay, and this is how you're going to do it on your homework. Okay, the degree. The degree is a 7, right? So if it's a 7, therefore it's odd. Okay? Degree is a 7. Leading coefficient, well, the leading coefficient is a 4. Leading coefficient is a 4. Well, 4 is for positive or negative. 4 is positive. So therefore, we got odd positive. So we're going to go back up here to our handy-dandy chart. What's odd positive? Odd positive. See that? Leading coefficient, it's odd, and leading coefficient positive. So a positive is going to look like this. So what's the end behavior? It's going to be this one. Does that make sense? Odd, positive. Odd, positive. So that's my end behavior. All right, and we're going to write that as x approaches negative infinity, y approaches negative infinity, as x approaches positive infinity, y approaches positive infinity. And there we go. Okay, next. Hope you guys are in for the long haul. This is a long lesson. All right, so what do we got here? Degree, leading coefficient, degree, 6. Okay. Leading coefficient is negative 9. Okay. Degree is 6, leading coefficient is negative 9. So we have even, and we have negative. Okay, even negative, which one's that? Even negative. There we go. This one, that's my end behavior. as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. Okay, number 3. Okay, well, what's this? Okay, now notice this is not factored. Okay, here I got it factored for me. So what is the degree? Okay, what is the degree? Well, this is x to the 1 and x to the 1. So 1 plus 1 gives me x to the 2. So the degree is 2. Does that make sense? Okay. Leading coefficient. Well, what's the leading coefficient here? Well, the leading coefficient is right here, which is a 1. So this is even and positive. All right, even positive. What do we got? Even positive. There we go. There's my end behavior. Even positive. As x approaches negative infinity, y approaches positive infinity. X approaches positive infinity, y approaches positive infinity. Okay. Number 4. Okay, moving right along. Number 4. Okay, so what's the degree here? The degree here, all right, we have a 1 plus 4 plus 1. Everybody see that? The degree, 1, 4, 1. So the degree is 6. Leading coefficient is 5. Okay, degree, 1, 4, 1, 6. So we got even, positive. All right, even, positive, even, positive. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity. Okay? All right, what's my degree here? Leading coefficient, degree. 1, 2, 3. 1, 2, 3. 3, that's odd. And leading coefficient, negative 5, that's negative. Odd, negative. Odd, negative. Okay, odd, negative. As x approaches negative infinity, y approaches negative infinity. I'm sorry if you're bored. As x approaches positive infinity, y approaches negative infinity. All right. And lastly, all right, what is my degree leading coefficient? 2 plus 3. All right, that's 5. That's odd. And negative 2. So that's negative. Odd, negative. So therefore, same thing. I'm not going to write it again. There you go. All right, so far on this first page, we've talked about end behavior. Here are the different types, which I will show you my hand gestures at the end. And then we determine the degree, the leading coefficient, and the end behavior. Okay, and you can set it up just like this on your homework. Okay, the next page. Okay, so now we're going to talk about, we're going to determine zeros of each polynomial and state the multiplicity. Okay, so we're going to determine the zeros and then state the multiplicity for each zero. Then determine whether the graph crosses or bounces, touches the x-axis and turns around. That's called bounces. Okay? All right, so let me explain what that means. Okay, so in the first problem, we're going to determine what the zeros are. So this goes back to solving by factoring, okay? So a number outside, that's 0, okay? All right, and then here, x equals 4, x minus 4, x equals 4, x plus 5, x equals negative 5, okay? X equals 0, x equals positive 4, x equals negative 5. Okay, so those are my x's. Now, next, I'm going to decide if it crosses, or I'm going to take the multiplicity, and then I'm going to decide if it crosses or bounces. Okay, so basically, if it's odd, it crosses. Okay, I'm sorry. If it's a multiplicity of 1, see how it's a multiplicity of 1 here? So therefore it crosses. So here it crosses. Okay. Multiplicity of 1. Multiplicity of 1. And I can just put m for multiplicity. Therefore these cross. I should probably write x-axis. Okay, now look at the 4. See how it's even? See how it's even? That has a multiplicity of 2. And therefore that bounces. Okay, let's go to the next one. All right, first thing we're doing is determining our x's. Okay, remember if it's a number you ignore. So x equals positive 4, x equals negative 5/3, x equals negative 7. We ignore that. Okay, positive 4, negative 5/3, negative 7. Okay, so we're going to decide, again, if it's even, it bounces. If it's odd, it crosses. So here, that's even. So this bounces. Here, this bounces. Okay? Here, this crosses. Okay, now, what's the multiplicity? The multiplicity of 4 is 2. The multiplicity of 5/3 is 1. The multiplicity of negative 7 is 4. Okay, let's try number 9. Okay. Okay, well, for this one, I need to, can't write x equals, oops, I need to factor it. F-I-R-S-T. Okay? So, I need to take out a greatest common factor, which would be an x. X squared minus 4x plus 4. Okay. And now I'm left with x and x, 2 and 2, minus, minus. All right. So final answer, f of x equals an x, and then x minus 2 to the second power, right? Okay, so what are my zeros? X equals 0, and x equals 2. 0 and 2. All right, so now, let's see what happens here. My 0 is to the first power, so that crosses x-axis and has a multiplicity of 1. My 2 bounces and has a multiplicity of 2. Okay. And number 10, let's factor this. Factors, let's see, no GCF, so factors of 9 that add up to 10. x2, x2, 9 and 1, minus, minus. Hey, those are difference of squares. Okay, so x plus 3, x minus 3, x plus 1, and x minus 1. All right, so I got 4 x's. I got negative 3, I got positive 3, I got negative 1, and I got positive 1. Okay, so they're all multiplicities of 1, which mean they all cross. All cross x-axis, and all M1. Okay, so again, to help you remember, this is a little chart, okay, which is for my little hand movements. This is even positive, even negative, odd positive, odd negative. Okay, and also to help remind you, okay, this is very important right here. Okay, to graphing, which we're going to do next. To find the real zeros of the function, okay, we use the zero product property, which is what we did to find the zeros. If it's even, okay, then the graph touches the x-axis, meaning it bounces, right? If it's even, it bounces. If it's odd, it crosses, okay? We're going to determine the end behavior, okay? And then this is to graph. We're going to find the y-intercept. We're going to determine the maximum number of turning points, which I'll explain. And then we're going to find points on the curve. So now we're going to graph. Okay, so here we go. It's graphing time. So these next 4 problems we're going to graph. We're going to make this nice and big. We'll go one graph at a time. Okay, first problem. So we got to graph this. All right, and in order to graph this, I need to factor. Okay, I see 4 terms up. I got to factor by grouping. All right, so greatest common factor. The first 2, I got x2. And I'm left with x plus 2. Greatest common factor of the first 2 would be negative 1. And I'm left with x plus 2. I get x squared minus 1 and x plus 2. Of course, I'm not done. That's the difference of squares. X plus 1, x minus 1, and x plus 2. So here's my problems, f of x equals. All right, so now I need my x's. X equals negative 1, positive 1, and negative 2. Okay, that's nothing different than what we already learned. All right, so here's my zeros. All right, great. Let's talk about the degree and the leading coefficient. Again, nothing what we don't know already. All right, so the degree would be 1, 1, 1, 1, 2, 3. Leading coefficient is a 1. So what do we got? We got odd and positive. All right, so what does odd positive look like? All right, you have to go back. Odd positive looks like this. I'll draw you the sketch, but odd positive is this. Okay, that's odd positive. Okay, so that's what it's going to look like. Now, the end behavior, okay, as x approaches, so odd positive, that's negative, negative, and positive, positive. So as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Okay? Maximum number of turning points. Now, the maximum number of turning points, the definition of it is 1 less than the degree. So what's my degree? Degree is 3, so the maximum number of turning points is 2. All right, so make sure you understand that. Okay, that's the definition. All right, y-intercept. What's the definition of y-intercept? Back to basics. Let x equal 0. So people, let x equal 0. What do we got? 1 times -1 times 2. So that's -1 times 2 is -2. 0, -2. Okay, let x equal 0. So now, what am I doing here? I got a graph. How am I using it? So I'm going to plot these zeros. I'm going to plot a -1. I'm going to plot a +1. I'm going to plot a -2. I'm going to plot the y-intercept 0, -2. All right, great. So I have these 4 points plotted. Now, what I'm going to show you guys here, we don't really need the XY table. We're just going to make a sketch. See this? How it says the maximum number of turning points. So that means how many times is it going to turn? Okay. Basically, it's going to turn 2 times. See this where it's odd positive? That means that this point and this point's going to go this way. And this point's going to go this way. Okay, so now I need 2 more turns. I need 2 more turns. So that means it's going to go like this and like that. And that's just a sketch. I know that my farthest point to the left is going to go down. My farthest point to the right is going to go up. That's what the end behavior determines. All right, let's try the next one. Okay, gotta take out the greatest common factor here. Let's see, that would be a negative x2. And I'm left with negative into negative is positive x2 minus 16. I got a difference of squares. Okay, which would be x plus 4 and x minus 4. All right, so my zeros are 0, -4, and positive 4. Okay, 0, -4, and positive 4. Okay, I need a degree. I need a leading coefficient. My degree, 2, 3, 4. 2, 3, 4. Degree is a 4. Leading coefficient is a negative. So what do we got? We got even and negative because my leading coefficient is -1. All right, so I got even and negative. All right, let me draw the sketch of what even negative looks like. That's even negative. Okay, so even negative, that's negative, negative, and this is positive, negative. So my end behavior as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. That's my end behavior. All right, my y-intercept, let x equal 0. Let x equal 0. 0 times 4 times 4, times -4 is still 0. So my y-intercept is 0, 0. Okay, so I'm going to plot 0, -4, and positive 4. And 0, 0 is still there. Okay, maximum number of turning points. What's the definition of maximum number of turning points? Right here, 1 less than the degree. What's the degree for? Maximum number of turning points is 3. All right, I filled in everything. Now I need to know the maximum number of turning points is 3. My end behavior, it's going to be here and going to be here. Okay, so number of turning points, so it's got to turn 3 times. So And we know that it's going to bounce at 0. See, I know it's going to bounce at 0 because there's a multiplicity of 2 here. See here, it bounces here. It's a multiplicity of 2. It bounces here. It crosses at -4, it crosses at +4, but it bounces here. So it's going to go like this. Looks like the McDonald's. And again, this is just a sketch. Okay, if I wanted, I could plug in a 2 and a -2 in the XY table. But again, we're just making a sketch. Okay, but it would give me an exact number if I plugged in 2 and -2. But I know that there's 3 turning points, and I know it's bouncing at 2. Okay, because it's bouncing at 0, excuse me, because it has a degree of 2. All right, next one. We're going to factor. We're taking out an x squared. Now I'm left with x2 minus 9, which is x plus 3, and x minus 3. I see a degree of 2, so I know it's going to bounce at 0 here, guys. See the degree of 2? It's going to bounce at 0. X equals 0, x equals -3, x equals +3. It's going to bounce here. Okay? -3, 0, +3. Okay, so the degree is 2, 3, 4. And the leading coefficient is 1, so therefore it's positive. So now we have even positive. Even positive looks like this. Okay? So my zeros are 0, -3, and +3. My end behavior, this is positive, positive. This is negative, positive. So as x approaches -infinity, y approaches +infinity. As x approaches +infinity, y approaches +infinity. Okay, my y-intercept. Let x be 0. Let x be 0. 0 squared is 0 times 3 times -3, that's 0, 0, which is right there. Maximum number of turning points, 1 less than the degree. 4 minus 1 is 3. Okay, so now remember the end behavior is going to look like this, going to look like this. Okay, so now 3 turning points. It's going to bounce here. So here's 1. It's going to bounce. It's going to go like this. That's the sketch. See? 1, 2, 3. And realistically, what numbers would I use? Well, this is a -3, this is a 0. So I would use a -2, a -1, a 1, and a 2. But again, we're just using a sketch. But if I plugged in -2, I'd come out with -20. If I plugged in -1, I'd come out with -8. If I plugged in 1, I'd come out with -8. If I plugged in 2, I'd come out with -20. And the last one. Taking out a greatest common factor is x squared. And negative x squared, sorry. And I'm left with x minus 3. Okay, so x equals 0 and x equals 3. Again, look at that. We know it's going to bounce. Bounces, because that is a multiplicity of 2. Okay, we got 0 and we have 3. Right, so the degree is 2 plus 1. The degree is 3. My leading coefficient is -1, which is odd. All right, so we got odd, negative. Odd, negative. Odd, negative goes up here and down here. That's odd, negative. Okay, so that's negative, positive, and positive, negative. All right, so my zeros are 0 and 3. My end behavior as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative infinity. Okay, y-intercept, plug in x for 0. 0 times negative 3, that's 0, 0. Maximum number of turning points, 1 less than the degree. 3 minus 1 is 2. Okay, so now, here are my 2 zeros. It has to look like this. So the one to the left goes up, the one to the right goes down. Now, it has to have 2 turning points. At 0, it's going to bounce. So it doesn't go through. It's going to bounce up. And it's going to be like this. And again, I could use an XY table. What's in between 0 and 3? 1 and 2. If I plug in 1, okay, and plug in 2, you get 4. I'm sorry, if you plug in 2, you get 4. If you plug in 1, you get 2. And realistically, I could, like I said, we're just doing a sketch, but I could plot the points. Plug in 1, 2, which would be right here, and 2, 4. I mean, granted, it's off, but it would be right here. But again, we're just doing a sketch. And that's graphing. The last page of the notes. I told you this is a long video. Is going to be matching each equation with the corresponding graphs. Okay? And the best way to do this is to decide okay, by the degree. Okay, to decide which is which. Okay? So on this problem, okay, we know the degree is negative, and this is 1, 2, 3. So here, this is odd, negative. So which one is odd, negative? Here, 1, 2, 3. That's odd, positive. Here, 1, 2, 3, 4. This is even negative. Here, 1, 2, 3, 4. This is even positive. So it's just a matter of deciding what's what. Okay, so give yourself a minute to think about it. Okay, and decide. So this is odd, negative. Okay, which one is odd, negative? Well, odd, negative looks like this one. This is odd, positive. Which one is odd, positive? This one's odd, positive. It's that one. Okay, then we got 1, 2, 3, 4. This is even, negative. Which one's even negative? There we go, even negative. And obviously this one is even positive. That's even positive. And here we go. Okay, so now I'm going to show you my little dance. Okay, so hold on while I try to figure this out.